So in this video we'll look about motors, what are motors and different types and their uses and their technical details. So motors are basically devices which convert electrical energy into mechanical energy, and it produces rotational motion or linear motion. So it's used in a variety of applications including automotive, industrial machinery, household and robotics and more. And there are several types of motors which I'll come to. But basically the idea is to convert the electrical energy into mechanical, and this is widely used especially in automotive industry and in robotics, which is like very important topic nowadays, because the industry is moving towards e-vehicle, electric vehicles, and therefore major car manufacturers are moving towards electric vehicles where you have a battery and which basically drives a motor, and therefore this motor concept is quite important to learn and understand for your skill set. And also it's also used in widely in robotics, and you see, since we are going into an automation age and artificial intelligence is taking up, and robotics is also playing a major role. And when you think about robots, it's about rotationary motion. Motors are key part of any robot which moves its hands or turns its head, rotates its head or turns its robotic arm. Any motion of a robot involves a motor. So these are the key concepts which I want to discuss in this video. Many types of motors. The main two types are DC motors and AC motors. And DC is direct current and AC is alternating current. DC motors operate using direct current and consist of a stator and a rotor. And stator is as the name suggests, is a stationary part, and rotor is as the name suggests, a rotating part. So there are two main components of a DC motor, which is a stator and a rotor. The stator remains static, it doesn't move, and rotor moves, and they utilize the interaction between the magnetic fields to generate the rotational motion. That is the I will explain this deep into this concept of how motor moves later, but just to get you an overview. So how it works is basically the magnetic field between the stator and the rotor is what makes the whole motor move or produce a rotational effect. So the utilize the magnetic field is the one which is the core concept which generates the rotational motion. And the DC motors are often used in applications such as electric vehicles, fans, pumps, and small appliances. So these are basically the places where DC motors are used. And AC motors are alternating current motors, and AC motors operate using alternating current using various types such as induction motors and synchronous motors. So the AC motors are subdivided into induction and synchronous motors. um, Induction motors are most commonly used type of AC motors, utilizing the electromagnetic induction to generate the rotational motion. And AC motors are widely used in industrial machinery, HVAC systems, compressors, and others. So these are the core main types of motors which you have to understand. Just the DC motor and the AC motor. DC motors used in electric vehicles, and some vehicles in electric vehicles also use the AC motors depending on the requirements. So I'll get into more details later, but just for now understand that DC and AC motors are two different motors, and DC operates on direct current, like battery delivers a direct current, and AC motors works on alternating current. And you note that the plug point which we have in our homes are basically delivering alternating current. Then we go to now the brushless DC motors, which is another type of motor which is commonly or has also wide applications. So brushless DC motors are similar to brushed DC motors, but they do not have brushes and commutators. So these are the main points of brushless DC motors, and they utilize the electronic commutation using sensors and sensorless techniques to control motors operation. So BLDC motors offers advantages such as high efficiency, longer lifespan and smoother operation. They are commonly used in appliances, and computer cooling fans use BLDC motors, drones and electric vehicles. So since it's brushless, it has more lifespan. There's no touching part or parts which touch each other. And there's another type, brushed DC motors are a type of DC motor which is commonly that uses a commutator and brushes to control the flow of current in the rotor windings. They have a simple design and are often used in small applications such as toys, power tools, and electric vehicles. So, brushed DC motors are used in power tools, electric vehicles also, but it depends on the application. So it depends on the applications. And there's a stepper motor, which is the small motors which you find in you quite often in your hobby projects. Stepper motors are designed to move in discrete steps. That's the crucial part of a stepper motor, and providing precise control over rotational linear motion. And they consist of multiple electromagnets arranged in a specific pattern, allowing for precise positioning. Stepper motors are widely used in applications such as 3D printers, CNC machines, robotics, and in automation system. Again, it depends on the application. For example, if you need a smooth movement, you don't use a stepper motor, but if you need a discrete movement, you do use a stepper motor, especially for CNC machines and other applications. These are just a few examples of many types of motors. Each type has its own advantages and disadvantages, and the selection of the motor, as I told, is depends on the application and such as required torque, speed, control requirements, power source, size, and for example, if you are building a bigger car, you might need a bigger motor. If smaller cars, smaller motor. Bigger robots, bigger motor. Smaller robots, and robots which do specific functions. If the robot is doing a discrete operation or function, then you'll need a sort of a stepper motor application. So it all depends on how you your application. So these are the common types of motors which I give given through. Then in the next coming videos or slides, I'll put more on go deep into the topic.